Welcome to the first video of the chemistry unit within COGO. Today we're going to talk about ozone dissociation. Today we're going to talk about the effects of ozone, the ozone dissociation, and the catalytic destruction of ozone. Ozone, or also known as O3, is a highly reactive gas composed of 3 oxygen atoms. This is both natural and artificial and can be found in the Earth's upper atmosphere. Now, depending on the natural or artificial kind, it is either good or bad. There are 2 types of atmospheric ozone, the artificial kind and the natural kind. The artificial kind resides in the troposphere and is bad for the environment and organisms living on Earth. The natural kind can be found within Earth's stratosphere and is often referred to as the ozone layer. This type of ozone protects all of Earth from harmful UV rays in space. Stratospheric ozone, or also known as the ozone layer, resides about 6 to 30 miles above the surface of the Earth. This is formed naturally through the interaction of solar ultraviolet radiation, or also known as UV radiation, with molecular oxygen, also known as O2. This type of ozone blankets the Earth's surface and reduces the amount of harmful UV radiation from reaching Earth's surface. This is known as good ozone. Tropospheric ozone, or also known as surface ozone, is a bad kind of ozone and is formed primarily from photochemical reactions between 2 major classes of air pollutants, volatile organic compounds, VOCs, and nitrogen oxides. This often contributes to what is known as smog or haze in major cities. The effects of ozone can be good or bad depending on its type. The effects of the good ozone, or also known as the ozone layer as mentioned from before, is about 3 to 5 millimeters thick and resides in the stratosphere. Now, this forms as a blanket that saves the Earth from UV radiation and shields us from harmful radiation from space. Now, the effects of the bad ozone, or known as the surface ozone that resides within the troposphere, can cause cancer if it's breathed in. It can also impact evaporation rates, cloud formation, and precipitation levels, and can cause global warming. Ozone dissociation is when the ozone molecule, O3, separates one oxygen from the rest of it and turns it into an O2 molecule. In other words, ozone dissociation is when an ozone molecule becomes an oxygen molecule. Now, how exactly does ozone turn into oxygen? Well, to answer this question, we can look at the catalytic destruction of ozone. Using nitrogen monoxide as a catalyst, we get the equation NO plus O3 is equal to NO2 plus O2. And NO2 plus O equals NO plus O2, which gives us a final equation of O3 plus O is equal to 2O2. Now, notice that the NO in both equations are canceled out. This is due to its catalytic nature and will be expended in the reaction. CFCs, or also known as chlorofluorocarbons, are harmful to the Earth. These type of chemicals react with sunlight in the Earth's stratosphere to break down the protective ozone layer, which is the layer of gas that is in the stratosphere and shields us from damaging UV rays. Likewise, we can use CFCs, or chlorofluorocarbons, to create a chain reaction that destroys ozone. Thank you so much for watching, and I really hope that you enjoyed this video. Always remember to never stop learning, and I'll see y'all in the next one.